Hi, Assalamualaikum. I'm Syakir and I will discuss about introduction and background. For introduction, total elbow replacement provides the ability for people to recover the abundant loss of comfort and efficiency in the arthritic elbow. This operation would treat the proscriptive connective tissue in other hands, which often accompanies inflammatory disease. Sleep stabilizing joint surface may also be repaired after these surfaces are broken by inflammatory illness. The surgery for replacement will strengthen the elbow mechanics. However, it cannot make the joint as healthy as it was before the onset of inflammatory disease. The tendon and muscle around the elbow are damaged in many instances by prolonged neglect before the replacement of the elbow. The efficiency of the treatment depends on the patient's well-being and motivation, the elbow's condition, and the experience of the elbow surgeon. When the procedure performed by an experienced surgeon, the total elbow joint replacement arthroplasty typically contributes to enhance comfort and function of the elbow. The biggest change are in the patient's ability to sleep and to perform everyday life tasks. For background, a pain-free, movable and stable articulation is the fundamental prerequisite for normal elbow function. Functional failure of the elbow arises from the compromise of one or more of these fundamental elements. Many surgical techniques to treat elbow disorders have been developed. Resection arthroplasty, interposition arthroplasty and arthrodesis were used in non-replacement operation for the management of painful, debilitating elbow conditions. The damaged portion of the humeral and ulna are replaced with artificial components during complete elbow replacement surgery. A metal and plastic hinge with two metal stems makes up the artificial elbow joint. In the hollow section of the bone, called the canal, the stems fit inside. There are various kinds of substitutes for elbows, and parts come in various sizes. Partial elbow replacement still exists and can be used in very particular circumstances. The elbow of the biomedical implant, also known as the artificial human elbow, looks just like the real human elbow because it has the same function.
Assalamualaikum and good day everyone. So here I would like to continue with the material selection strategy for this stem part, which is ulna and humeral as well as pin. For the first step, which is translation step, the material for the stem must be high fretting strength and high fracture toughness. Since this material is going to be used in surgical implants, so it must be biocompatible and good corrosion resistance. The objective is to minimize mass and maximize yield strength. Then after determining the design requirement, the materials index is derived as shown in the slide and a bubble chart is created. The material chosen is titanium alloy, commercially pure titanium, nickel-based superalloy, medium carbon steel and low alloy steel. For the second step is screening step. The material properties of each possible material are retrieved from CF software. So here is the properties of 5 chosen material. Besides, in this screening step, each of us has screened the material by using the constraint that has stated in the design requirement table. So from the table, we can conclude that nickel-based superalloy and medium carbon steel are eliminated because they do not biocompatible. Next step is ranking step. After the ranking process, as we can see on the table slide, titanium alloy has the highest strength followed by the other two candidates. For the last step is the documentation step. Based on this step, titanium alloy is chosen as the best material for stem and pin as it gets the highest score among the two candidates. According to CF software, titanium alloy is typically used for surgical implant and it can be implanted in the body to repair the broken bones. As for the bearing component, all the 4 steps also been done and we can conclude that polyethylene is the best material for the bearing. Thank you.
Hi, Assalamualaikum. My name is NOREEN AQILLA binti KAMARUZAMAN for the shaping process for stem, humeral and ulna. First step, which is translating function to shape ulna and humeral. Constraint material is titanium alloy shape 3D, solid 3D. Good surface finish with close tolerance 0.05 mm. Objective to minimize cost. Free variable choice of process. For second step, which is screening, select 5 machine process regarding the constraint and objective. At translating step 1. The result get from the chest software. Based on the screening process, eliminate 3D printing and powder injection molding because they are not good in the surface finish with the close tolerance 0.05 mm. For the next step, which is ranking, after eliminate 2 machine process, another 3 machine process is ranking to know the best machine process for the ulna and humeral. Last step, which is the documentation. Based on the ranking process, EDM is the best machine for the shaping process because EDM has a good surface finish with the close tolerance 0.05 mm and low cost. In addition, EDM fulfill all the requirements in selecting shaping part for steam. Lastly, EDM is widely used in the biomedical, orthopedic, and aerospace application. Thank you.
Hi, Assalamualaikum. My name is AZNIERA. So for now, I'm going to talk about finishing and joining process for stems. The function of the stems is to aid the broken elbow. The primary process of the stems is electrodischarge machining. For constraint, the material is made by titanium alloy. The shape is 3D solid. It must be able to produce rough surface finish. The coating thickness range is 15 to 200 micrometer. It must be coating on certain surface area only. For objective, maximize surface porosity and minimize cost. Free variable choice of process. The process candidate is electrolysis plating, metal film spray, anodizing, polymer powder coating, and vapor metallizing. All the data is collected from the CES software. Process electrolysis plating, anodizing, and vapor metallizing is eliminated from the selection because those processes are not able to coat only on the specific area. The chosen process is metal film spray. It is because this process is suitable to create a porous surface finish on top layer of the stems. The cost for metal film spray also in a medium. It is able to coat a thin layer of titanium alloy on the selected surface area of the stems. Function to join 3 different components, which is the stems, polyethylene bearing, and 2 snap pin. Constraint, it is the combination of titanium alloy and polyethylene. The shape is 3D solid and prismatic circular. It must able to stand tension stress from stem. It must easy to be assembled and disassembled. The joint must allow rotational movement of the hinge and the stems. Objective is minimize cost, and the free variable is choice of process. The process candidate is snap fit, threaded fastener, rigid adhesive, power beam welding, and rivet. After the screening process, the joining process by rigid adhesive, beam welding, and rivet are eliminated from the selection list because those processes are not able to allow rotational movement of the joint pieces and not easy to be assembled during the operation by the surgeon. Snap fit is the chosen one because this is a low-cost process. It is suitable for joining 2 different material and shape. It also able to support tension loading. It allows rotational movement and easy to be assembled and disassembled.
Hi Dr. Zaleha and my fellow friend. My name is Nik Muhammad Syarah Amir bin SHAHIRAN. So today I'm going to talk about processing parameters. So the process involved is electrodischarge machine (EDM). The effect is EDM will make the surface rough when the pass current at maximum while pass on time will cause erosion of the product. The spark frequency will decrease the surface roughness of the product. Then the process is metal spray. The effect is the distance between spray gun and the product will affect the coating thickness that will affect the surface roughness. The heat need to be controlled so that the coating will be perfect. The other process is compression molding. So the effect is both pressure and heat will make the molding effective to produce our product. The cooling rate will produce a good stress-reduced molded part. Next is the snap fit process. The effect is elastic modulus will make sure the product is resistant to deform elastically when the force being applied. Then the sheet forming process. Its effect is thickness of the sheet metal will affect the product and deformation will occur such as crack and fold. The punching tonnage will reduce the deformation on the product. And the last process is vapor metallizing (PVD). The effect is oxidation state will prevent the product from rusting. Shaping process for humeral and ulnar part is electro-discharge machine (EDM). So EDM use electric spark as cutting tool to cut workpiece and finish until desired shape. Workpiece will be put in the dielectric fluid, then the power supply will generate rapid electric pulse that create a discharge. Discharge will create plasma causing the melting and evaporation of material. For the finishing process, we use metal flame spray process. Flame spraying use all heat to melt the spray coating material from the combustion fuel of gas. The gas stream accelerates them and propels them toward the surface. The molten particle will interlock and bond them as they solidify after it strikes the surface. For the bearing shaping process, we use compression molding process. Compression molding process is a process of molding the material. Generally, the material is preheated before the materials are put in the heated mold cavity. The mold is closed and with the top of the mold, and the high pressure applied to the mold force the material to fill the mold area. The heat and pressure are kept maintained until the molding material has cured.
My name is Muhammad SYAZWAN bin SALIMI. We continue from the last part of bearing processing. The next process is snap fit joining. Snap fit is a process that doesn't involve any heat, forging, welding like any other mechanical joining. It's just like mechanical fastening. The joining process is very fast, at the same time it's cheap. The best part for the joining process is all the parts are interlocking with each other by the pushing some part to attach them. This advantage can make the part joint fit safely. This joint was selected for this process because the snap fit process can join the different material, color and texture. This process can attach humeral and ulna, which is titanium, and the bearing is polyethylene. In this process, bearing are pushed into the lock and the bearing are fit to the humeral and ulna. The next part is hinge pin. The hinge pin is component are used to connect humeral and ulna that has been attached with bearing. Hinge pin was selected because the component can join two parts keep together and allowing the part move freely. The best material to make hinge pin is titanium. We move to the primary process for the hinge pin, which is sheet forming. Sheet forming is a process that applies force to a piece of metal to change its shape without causing any material loss. The sheet forming starts with material stock and giving the product an almost constant cross-section unless folded. Press forming covers a range of sheet forming process that use die and press the sheet to get the required shape. In roll forming, a continuous sheet metal will move through the series of rolls that will shape the sheet at required shape. This step is perfect for long length, constant, and sometimes is complex for cross-section. Next, the finishing process for hinge pin is vapor metallizing PVD process. The process are suitable for titanium nitrate to coating the hinge pin, which is titanium. The titanium nitrate are good for bone growth and not reactive material, which is safe. PVD metallizing is a process where a thin coating of metal is deposited from a vapor onto a component. The vapor is created in a vacuum chamber by direct heating or electron beam heating on the metal, and the condensation occurs on the cold component. This is production process flowchart for total elbow replacement.
Hi, my name is Muhammad HAQIM and I would like to continue my group presentation about effect of parameter. Effect of parameter for humeral and ulnar implant. There are three effect of parameter, which is non-reactive material. Ensure that the implant will not interfere with the chemical structure in human body. Second, good for bone growth. Bone growth help in anchoring muscle, storing calcium, providing structure and maintaining bone density. Third, lightweight. Lightweight material is important in surgical instrument industry to prevent unstable of the total elbow replacement. Effect of parameter for bearing. First, less stress. The elbow replacement will strain in a small amount and deformation can be reduced. Second, less friction. Important for efficiency, which is can reduce wear and premature failure of the bearing. Third, wear resistant. Ensure that the elbow replacement will last longer and support the excessive force or load of the joint. Effect of parameter for hinge pin. First, good fracture toughness. Ensure that the component can tolerate a longer crack before fracturing. Second, wear resistant. Ensure that the elbow replacement will last longer and support the excessive force or load of the joint. For testing and quality control, there are 7 methods of quality control, which is durability test, surgical process, bone resorption, tricep sparing, stability, and humeral stem.
Type of defect and countermeasure. For the first type of defects is defects of materials. Defects that occur due to defective and insufficient construction material. Such deficiencies come from the supplier and inability to deliver reliable and well-organized building records. Typically, error requires some kind of overhaul and replacement. The countermeasure is the introduction of a strong regular report system and evaluation plans is a helpful method for avoiding defects. Having this well recorded and doing regular work and material checks may help spot problems early on. Second is metallography. Metallography is conducted on parts working at critical temperatures. With the pressure test, the titanium alloy were tested using standard tap water after welding. Then a few days showed signs of reddish corrosion and leakage from surface warts. The countermeasure is 2 aspects of scanning electron microscopy (SEM), energy dispersed spectroscopy (EDS), and metallographic microscope (OM) were used to investigate the cause of corrosion and leakage in the flattening experiment. For example, metallographic examination and fracture analysis. Lastly, the ability to withstand load. During the diametric testing, some of the sample broke. It was possible that the shattering into tiny pieces retained so much tension energy in a sample that a large number of surface had to produce to relieve the energy. However, if all the other samples were to start with a similar pattern, factory was supposed to relieve excess energy more. The countermeasure is the responsibility of mitigating construction defects and instability rests with everyone on the project. Proactive steps may be taken to minimize the risk of encountering them. For instance, implement quality management programs and act rapidly. As a conclusion, while replacement of the total elbow is much less common than replacement of the knee or hip, it is just as effective in relieving joint pain and restoring individuals to activities they enjoy. Replacement elbows include stumps and hinges. The stump is for the replacement of the straight bone and the hinge is for the elbow's rotational movement. Various material and process selection techniques have been carried out for the humeral, ulna and hinge of elbow replacement, each precisely focused on function and other criteria such as goals and constraints. The material chosen to produce the humeral, ulna and hinge component is titanium alloy. While the material is the same for both components of the elbow replacement, different manufacturing methods can produce them. The humeral and ulna is produced using electrodischarge machine, EDM, while the hinge is produced using sheet forming.